always around why it looks so different, right? Because people are so used to go to outcrops where the sands are more prevalent, and you see scouring and cuts and all that. And that's a simple reason, right? Because sands outcrop much better than the muds. So when you see a good muddy outcrop, treasure it because they are rare. Is when a sandstone that has a lot of water in the pores is overpressured, and could be by an event bed just being deposited on top of it. So then that sandstone become overpressured, and then basically the bed explodes. So it starts to shoot rays of sand, not only towards the top, but sideways, sometimes downwards as well. And when some of those injectites reach the seafloor, because this is happening very close to the seafloor, right? So that first sand was deposited at seafloor, and then comes a debris flow on top of that. Now that's the top of that debris flow is the seafloor. So the injection, if it reaches the seafloor, will form a sand volcano. And we are going to see examples of sand volcanoes in the same formation where outcrops in La Jolla. There are some good examples of nicely preserved outcrops showing different types of muddy deposits. But on the deep water side, maybe the most important are the levees, because the levees are a much more common feature than we thought in the past. And the reason why it was hard to recognize previously is because they can be so big that they are actually bigger than the scale of 3D blocks sometimes, right? So if a channel system is 2 or 3 kilometers wide, just one wing of the levee can be 20, 30, or 40 kilometers wide, right? So how can you see that in an outcrop? Exposures like that are excellent would be just a really small window of that major archetype. So those are the two different types of gravity flows in the water. And the key difference is that in turbidite, the grains are coming down the slope in suspension, and the position will occur where there's a subtle change in gradient, where the gradient actually gets not as steep. Then with that, flow velocity will slow down, and the material in suspension might start to rain down according to its different settling velocities. In the case of debris flow, the entire flow comes down as a one cohesive mass, like a toothpaste, and depositions by freezing. It's just stop and freeze in place, and the formation to form a debris flow normally is associated with catastrophic events or could be associated with catastrophic events in the upper shelf, upper slope or outer shelf, where you can even have an association of extensional faulting up deep, debris flow, and compressional in a compressional front in front of that MTC because of the way that the MTC is stopped, right? So it's so dramatic that caused a series of thrust faults.